All right, today we finish up with the scientific revolution. Throughout this time period of the Renaissance and the Reformation, we see a lot of changing views of religion, of the world, of all kinds of stuff going on, art, everything seems to be changing. Well, science is going to change as well, so it's not going to be really anything different from anything else. It's going to have its own ups and downs. Now, remember, there was a revival of learning from the Romans and the Greeks during this time period, and so they were looking at the teachings of Ptolemy. And Ptolemy said that the Earth was the center of the universe. And for Europeans at this time, that made sense to them. It agreed with their common sense that, of course, we're the center of the universe. That makes sense. It follows the teachings of the church. It all kind of comes together. And so when we see people that are going to be challenging that idea, it's going to cause somewhat of an uproar. So we start off with Nicholas Copernicus. And Nicholas Copernicus was a Polish scholar. And in 1543, he publishes a book called On the Revolutions of the Heavenly Spheres. And in this book, he basically says that we are not the center of the universe. Instead, our universe is heliocentric, which means it's sun-centered. The sun is the center of the universe, not the Earth. The Earth is just one of the many planets around it. Now that was just amazing to people. First off, they just didn't believe it. It was too far beyond their comprehension. And so it's going to be rejected by experts as well, because basically they said, well, if Ptolemy is wrong about this, if he's wrong about us not being the center of the Earth and Copernicus is right, then maybe a bunch of our other thinking is going to be wrong too. And we don't want our other thinking to be questioned, especially if it's something that has to do with the church or has to do with the government or has to do with rulers. We don't want that questioned. So we're just going to say he's wrong. That's just what they're going to do. Well, eventually Tycho Brahe, who is a Danish astronomer, is going to support Copernicus's theory with evidence. So he's going to say, I happen to believe Nicholas Copernicus, and I have the proof to back it up. So Copernicus also had some proof, but not a lot. Brahe is going to be the one who supports it with actual hard evidence. And his evidence is that he had observed the movements of the heavenly bodies for years. So he was watching Venus, and he was watching Mars, and he was watching the moon, and all kinds of stuff. And he tracked the progress throughout the year. And he says, this is the only thing that makes sense. The only thing that's going to make this make sense is if the sun is the center of the universe. Otherwise, there's no way that this could work. No way it could happen. Then we get Johannes Kepler, who is Brahe's assistant, and he's a German astronomer and a mathematician, and he's going to use that stuff from Brahe, and he's going to use that data to calculate the orbit of the planets. And his calculations also support Copernicus. And so we're starting to see this buildup of evidence that Copernicus was actually right. Oh my goodness. Then we get a man named Galileo Galilei, and he is an Italian, and he assembles an astronomical telescope, which means it can look out, it's used for astronomy. And he is the first to use this telescope to see mountains on the moon, and he's the first to see sunspots. So he's looking at the sun, which is probably not good for your eyes, but he's the first one to see the dark spots on the sun. He also is the first one to see 4 moons of Jupiter. So all kinds of stuff. But the church is going to condemn Galileo because he challenged the church's teachings that the heavens were fixed and they were unmoving and they were perfect. And he's saying they're not fixed, they are moving, and they're not perfect. They change. And so the church doesn't like that. They don't like being questioned, and so they're going to bring him to trial before the Inquisition. Now remember, the Inquisition was that church court that could use torture, and it could use execution as a threat and all kinds of stuff. So it's got some powerful backing. And eventually they're going to threaten Galileo with death and basically say, you take back your statements or we're going to kill you. And so, under pressure, he publicly stated that the Earth was the center of the universe. But as soon as he's let go, he goes back to continuing to do his science, and he comes up with the new scientific method, that this idea of observing and experimenting, and then observing again, and keep experimenting and see what changes happen, and keeping things constant, that there's a process to actually studying science. And eventually, if you get something that is proven over and over and over and over again, you can convert that to like a natural law, a scientific law. And so he goes back to, compiling more evidence that's going to back up his theory. Someone who uses that scientific method to his own advantage is going to be a man named Isaac Newton, and he is an Englishman. And he develops a theory to explain why the planets move the way they did. He understood that the planets moved. He got that. He was a big proponent of Copernicus and Galileo, but he wanted to understand why they were moving the way that they did. And so that is how he comes up with the theory of gravity. Now, the story goes that an apple fell out of a tree and fell on his head, and that's what, got him thinking about gravity. But he realizes that you could use math to show that gravity is keeping the planets in orbit around the sun, that if they follow this path, there's a reason for it, and you can get a mathematical equation that can predict where it's going and can predict the ellipse or the orbit of these planets. And they have to be doing it for a reason, and the reason is because of gravity. Something's pulling them to the center, and that would be the sun. So it's sun-centered, backing up Copernicus. But he also is going to say, well, nature follows uniform laws, that all motion can be measured, it can be described mathematically. So, Newton's laws, like for every action there is an equal and opposite reaction. Those kinds of things, that comes from this time period where they start thinking about these things. We also see some more scientific advances, like in chemistry. In chemistry, in the Middle Ages, you had a group of chemists. I really hesitate to call them actual chemists, but they are called alchemists. And alchemists believe that everything has magical qualities, and all you have to do is tap the right quality, and you could change stone into gold. And if you wanted to become a rich person, all you had to do is figure out that magical formulation, and boom, all your rocks in your garden are going to become gold, and you'll be rich, kind of thing. Not a whole lot based on science and scientific method. They just experimented. They started throwing all kinds of weird stuff together, hoping to make gold, and it never worked. But so in the Renaissance period, we're going to see some advances finally in chemistry, and that will come with Robert Boyle. Robert Boyle is going to be the guy who starts dividing things into individual elements and chemical compounds. He's going to start doing some research on the effect of temperature and pressure on gases, making them expand and contract and condense and all kinds of stuff. So he's doing some really cool stuff that you learn about in chemistry today, that who'd have thunk kind of stuff. Other scientific advances are going to come with things like medicine. A lot of advances in medicine, mostly because now they're starting to understand things that are happening. So you get Andreas Vesalius, who is going to make the first accurate and very detailed study of human anatomy. Now, he had to dissect a lot of dead bodies to get this, but we start to see the layout of muscle structure and bones and internal organs and tendons and veins and all kinds of stuff. Really cool stuff. Another one is Ambrose Paré, and he is a French physician, and he is going to eventually develop an ointment to prevent infection, that you would place this on your injury in order to prevent it from getting infected. And because if you got an infection in it, then you could maybe get gangrene, and then they'd have to cut it off, and you could lose a limb that way. So he realized that if you put this ointment, it's a preventative ointment, that this would prevent infection from getting in. What he's doing is killing germs, but he doesn't understand that part. He just knows that if you have an ointment made of these substances, that's going to prevent infection. Eventually, he also is developing a technique for closing a wound with stitches. So if you get like a huge stab wound or a sword or a knife wound, he could stitch that up. But he wasn't just closing the hole. He's also pulling the muscle and the tendons and all that kind of stuff together, rather than just sewing you closed and hope you heal kind of thing. He actually develops a technique for replacing and pulling things back together the right way. And finally, we have William Harvey. And William Harvey is an English scholar. And he is going to describe the circulation of the blood for the first time, of how the blood goes through your heart and that there's 4 chambers and how that actually could work and why does it go through your heart? Why does it have to go circulating through your whole body? Why does it have to go through the heart? What's the purpose? So he talks about that circulation system and how that could possibly function in a real person who's alive kind of thing. Again, he did a lot of study of dead bodies. So we do see, like I said, a bunch of advances in science as well as everything else during this time period.